So once again here, in order for us to find the value of A, we need to be able to kind of work through a couple different steps. One of the main problems with this question tends to be the interpretation of information. Okay, so in all of problem 10, everything with a dashed line, it's said to be an altitude. So that means that this value A, that's an altitude or a right angle. Also, this dashed line here, this 9, also an altitude. Okay, so what we can do here is we can use the fact that in a parallelogram, the area will be consistent no matter which direction you're measuring the area. So whichever pair of base and height, they're going to have the same product. So if we take this base and height that forms here, this green right triangle, I can solve for my area. If my base times height is base of 12, a height of 9, right, I know that that has to stay true. Well, the A is the height using the other base. And so we can find this other base. I'm just going to call it C, and the reason I'm going to call it C is we created this right triangle. Okay, so if we found this base C and then multiplied that by A, we should get 12 times 9, that's 108. And so let's see what happens. If we were to take these two legs of the right triangle, 9 and 12, have a common multiplier, or a common factor of 3. We have 3 times 3, 3 times 4, so we're looking at a common triple, a 3, 4, 5, with a multiplier of 3. So this C value, this base, is 15. So I could also write my base times height as 15 times A. And so now using this equation, 12 times 9 equals 15 times A, I can solve for A by dividing both sides by 15. And so if you calculate that, 12 times 9 divided by 15, you'll get your value for the height A.